Hi all, welcome to Software Future Academy. Today we are going to discuss about the topic mole concept. Actually in this session we are going to discuss some questions related to mole concept. Before moving to the question discussion, let's revise the topic. So what do you mean by mole? Mole is actually that is a particular value. Any substance contain what 6.022 into 10 raised to 23 particles. 1 mole of any substance contain 6.022 into 10 raised to 23 particles. Okay, so before that, what do you mean by GAM or GMM? GAM is actually gram atomic mass and the GMM is gram molecular mass. GM is what? Gram atomic mass and the GMM is gram molecular mass. For example, what is the atomic mass of hydrogen? Atomic mass of hydrogen is atomic mass of hydrogen equal to 1. What is the gram atomic mass of hydrogen? That is gram atomic mass we can denote GAM. GAM, that is gram atomic mass. Gram atomic mass of hydrogen is 1 gram. So the atomic mass expressed in gram is called a gram atomic mass. Okay. So gram atomic mass, that is 1 gram, that is also called 1 mole. That means 1 mole equal to 1 mole of hydrogen atom, which is equal to 6.022 into 10 raised to 23 atoms of hydrogen. 6.022 into 10 raised to 23 atoms of hydrogen. Okay, so 1 mole of hydrogen equal to 6.022 into 10 raised to 23 atoms of hydrogen, because this is atomic mass of hydrogen. Okay, so this is otherwise called 1 GAM. 1 GAM is equal to what? 1 mole of hydrogen atom. And another example is 1 atomic mass of oxygen. Atomic mass of oxygen is what? Atomic mass of oxygen equal to, that is 16. What is the GAM of oxygen? GAM of oxygen equal to 16 gram. This 16 gram is also called 1 mole, that is 6.022 into 10 raised to 23 what? Atoms of oxygen. Atoms of oxygen. Okay, that is also called what? 1 GAM of oxygen. 1 GAM of oxygen. Then what is 2 GAM of oxygen? 2 GAM of oxygen is, the mass is double, so 32 gram. 1 GAM of oxygen is 16 gram. 2 GAM of oxygen is 32 gram. That is also, that contain what? 6.022. 1 mole of any substance contain 6.022 10 raised to 23 particles. Either it is atom or molecule or ion. Okay, then what is GMM? What do you mean by GMM? GMM is what? Molecular mass expressed in gram. Molecular mass expressed in gram. What is the molecular mass of hydrogen? What is the molecular mass of hydrogen? That is 2. Okay, that is 2. Then GMM 2. What is the GMM of gram molecular mass of hydrogen? That is 2 gram. This 2 gram is also called 1 mole. What is the difference? That contains 6.022 into 10 raised to 23 molecules of oxygen. Molecules of oxygen. That is the difference. 1 GAM is what? 1 GAM that contain 6.022 into 10 raised to 23 atoms. What about 1 GMM? 1 GMM means 6.02 10 raised to 23 molecules of not oxygen, sorry, hydrogen. That is the difference. Then one more. What is the molecular mass of oxygen? What is the molecular mass of oxygen? That is 32 gram. Oxygen, that is 32 gram. What about the GMM of oxygen? GMM of oxygen, that is 32. This is 32 only. 32 gram. GMM of oxygen is 32 gram. This 32 gram is also, we can say that is also 1 mole. That contain what? 6.022 into 10 raised to 23 molecules of oxygen. Molecules of oxygen. Okay, what is 1 GMM of oxygen? That is 32 gram. 1 GMM of oxygen is 32 gram. Okay, what about in the case of compounds? Let us take an example of a compound, water. Molecular mass of water is what? Molecular mass of water. Molecular mass of water, that is 18, no? 18. So, what is the GMM of water? GMM of water, that is equal to 18 gram, isn't it? 18 gram. Okay. So, this 18 gram is also called what? 1 mole, which is equal to what? 6.022 into that contain, okay, 10 raised to 23 molecules of water. Molecules of water. That is not atom, that is molecule, because what? Water is a compound, no? Water contains 2 atoms of hydrogen and 1 atom of oxygen. So again, water, 1 mole of water equal to 18 gram, right? Okay, so 1 mole water contain 2 mole hydrogen and 1 mole oxygen. 1 mole oxygen. H2O, that contain 2 mole hydrogen and 1 mole oxygen. That is also important thing. So before that, sorry, after this discussion, so some equations are what we can calculate. Based on that, we can calculate number of moles, which is equal to what? Number of moles. The equation is given mass or mass in gram, given mass divided by GAM or GMM. Okay, so number of moles. We can calculate the number of moles based on the mole concept. Number of moles equal to given mass divided by GAM or GMM. What about number of molecules? Number of molecules. Number of molecules equal to number of moles multiplied with Avogadro number. Number of moles times Avogadro number, Na. Okay, Na is what? Avogadro number 6.022 into 10 to the power 23 particles. Either it is atom, molecule. Okay, so number of molecules, otherwise one more equation is, that is given mass divided by GAM or GMM times Avogadro number. Okay, number of molecules. What about in case of number of atom? Number of atom, that is equal to what? Number of molecules into number of molecules multiplied with atomicity, or how many atoms present in a particular compound. Atomicity. For example, H2O. What is the number of atom of water? 2 hydrogen and 1 oxygen. Total 3 mole. Sorry, 3 atom. So we can multiply with 3 here. Okay. What about in case of ammonia? How can you calculate the number of atom? So that is number of molecule times NH3. How many? Nitrogen 1 and 3 hydrogen. Total it is 4 atom. So we can multiply with 4 there. Okay. So again equation is what? Number of molecule times atomicity, and another equation is number of moles in multiplied with Avogadro number multiplied with atomicity. Okay, another equation is number of atom, that is number of atom equal to given mass divided by molecular mass. Given mass, number of atom equal to given mass divided by GMM or GAM multiplied with Avogadro number multiplied with atomicity. Another equation, number of atoms. Okay, so molar volume is also there. Molar volume. What do you mean by molar volume? Molar volume is volume of 1 mole substance. Volume of 1 mole substance at STP. Volume of 1 mole substance at STP. What is STP? Standard temperature and pressure. Standard temperature and pressure. Standard temperature and pressure means what? Temperature is 298 Kelvin and the pressure is 1 atmosphere. So the volume is what? 22.4 liter. 22.4 liter. That is called molar volume. Okay. Another concept is what? Limiting reagent. Limiting reagent. Limiting reagent. What is limiting reagent? A reagent that is completely consumed in a particular chemical reaction is called a limiting reagent, and the excess one is called a excess reagent. Reagent that is completely consumed in a particular chemical reaction, that is called a limiting reagent. Limiting reagent, we have to calculate the limiting reagent. That is very important because limiting reagent will decide how much amount of product is formed. So the limiting reagent concept is very important. Okay, let's move to the question. Question number 1. A mole of any substance contains dash. Mole of any substance contain what? Avogadro number of particles, right? So 6.022 into 10 raised to 23 particles. 1 mole of any substance contain 6.022 into 10 raised to 23 particles. So the option is C. Okay. Then next one, question number 2. Second one, 12.044 into 10 raised to 23 atoms of oxygen contain dash. 12.044 into 10 raised to 23 atoms of oxygen. Okay, 1 mole of oxygen is what? 1 mole of oxygen contain 6.022 into 10 raised to 23 atoms. 1 mole of oxygen, atoms of oxygen, right? Okay, here 12.044 into 10 power 23 atoms of oxygen equal to what? That is the question. Okay, 12.044 into 10 raised 23 atoms of oxygen contain dash. That is the question. So we know that what? 1 mole of oxygen or 6.022 into 10 raised 23 atoms of oxygen is equal to 1 mole. So what about 12 point? Actually, this value is the double of this one. Okay, so again we can take double here also. So the answer is what? 2 mole. 2 mole of oxygen. Okay, see, 6.02 to 10 raised 23 atoms of oxygen is what? 1 mole of oxygen. So what about in case of 12.044 in 10 raised 23? That is what? This value is the double, right? So again, we can take double of this one. So answer is 2 mole. Okay. Then question number 3. Question number 3. What is the number of particles in 10 mole of hydrochloric acid? Number of particles, that is, see, 1 mole HCl contain 6.022 into 10 raised to 23 particles, right? 6.022 into 1 mole HCl equal to 6.022 into 10 raised to 23 particles. So what about in case of 10 mole? 10 mole HCl, that is multiplied with 10 into 10 raised to 23 multiplied with the 10 particles, that is 60.22 into 10 power 23 or 6.022 into 10 raised to 24 particles. 6.022 into 10 raised to 24 particles. Answer option is A. Okay. Then next, fourth one, 1 mole of sucrose contains. 1 mole of sucrose contains how many grams of sucrose? 1 mole of sucrose contains how many grams? We know that molecular mass or atomic mass, that is equal to 1 mole. Okay, see, 1 gram hydrogen atom equal to 1 mole. 1 gram hydrogen atom equal to 1 mole, because 1 is the atomic mass of hydrogen. Then 16 gram oxygen atom equal to what? 1 mole, because 16 is the atomic mass of oxygen. Then 32 gram oxygen molecule equal to 1 mole. That means what? 32 is the molecular mass of oxygen. Like 1 mole of sucrose contain how many gram? Sucrose is what? C12H22O11. What is the atomic mass of carbon? That is 12. What is the atomic mass of hydrogen? 1. What is the atomic mass of oxygen? That is 16. So we can calculate the molecular mass of sucrose. So 12 into 6 plus 1 into 22 plus 11 into 16. Finally, we will get the answer 342 gram. This is the GMM of sucrose, gram molecular mass of sucrose. So molecular mass of any substance, that is equal to 1 mole, right? So 342 gram sucrose equal to what? 1 mole. 342 gram sucrose equal to 1 mole. So 1 mole of sucrose contain how many gram? That is 342. Answer is option A. Then let's move to the next question. Okay. Then fifth one, 1 mole of ammonia is of 17 gram. Then what is the mass of 0.3 mole of ammonia? 1 mole ammonia equal to 17 gram, right? So what about 0.3? 0.3 mole ammonia. 17 multiplied with 0.3. So the answer is what? 5.1. 17 multiplied with 0.3, that is 5.1. 5.1 gram. 1 mole ammonia equal to 17 gram. That is 17 gram is the molecular mass of ammonia, right? So 0.3 mole, 17 multiplied with 0.3. Answer is 5.1. Option B. Okay. Then let's move to the next question. Question number 6. How many gram moles oxygen are there in 88 gram carbon dioxide? What is the molecular mass of carbon dioxide? Molecular mass of carbon dioxide is 44 gram. Molecular mass of carbon dioxide, CO2, right? Carbon is 12, oxygen is 32, 16 into 2, 32. So 12 plus 32, that is 44 gram. This is molecular mass or 1 mole. How many gram mole oxygen are there? Question is, how many gram mole of oxygen? So see, 1 mole carbon dioxide equal to 44 gram. This 44 gram carbon dioxide contain 1 mole carbon and 2 mole oxygen, right? 2 mole oxygen. See, carbon dioxide, the molecular mass is 44. 1 mole carbon dioxide is 44 gram. Then 1 mole carbon dioxide contain, or 44 gram carbon dioxide contain 1 mole carbon and 2 mole oxygen. Again, 44 gram carbon dioxide contain 2 mole oxygen. What about 88 gram? It's simple, right? 88 gram contain what? 4 mole oxygen. 4 mole oxygen. 88 gram contain 4 mole. 44 gram carbon dioxide contain 2 mole oxygen. Then what about 88 gram? 4 mole. Option is D. Okay. Then question number 7. It's actually based on a limiting reagent. 1 gram of magnesium is bound with 0.56 gram O2 in a closed vessel. Which reactant is left in excess and how much? What is limiting reagent? Reagent that is completely consumed in a particular chemical reaction. Limiting reagent is very important because limiting reagent will decide how much amount of product is formed. Okay, first let's write the balanced chemical equation of this reaction. Magnesium is bound with oxygen. The equation is Mg plus O2 give MgO. This equation is not balanced. This is a skeletal equation. So we can balance this equation. 2Mg plus O2 give 2MgO. Okay. See here mass of magnesium is given. Then oxygen is also given. First we have to write the molecular mass of each reactant, because mass is given here. Both magnesium and oxygen given masses are given. So we can write, first we can write what the molecular mass of, that means mass of, what is the mass of in this particular equation, that is the molecular mass, right? So see here 2 mg magnesium, the 24 is the molecular mass, atomic mass of magnesium. First we have to write what the mass of the particular reaction, I mean equation. Mass of the reaction means, or equation means molecular mass, right, or atomic mass. Okay, here 2 mole magnesium, 1 mole magnesium is 24, atomic mass of magnesium is 24. Here 2 mole is given, right? So 2 into 24, that is 48 gram. Okay, oxygen is 32 gram. Then write the mass of the magnesium 1 gram, here 0.56 gram. You have to calculate which reactant is left in excess and how much. Here 48 gram or 32 gram oxygen combined with 48 gram. We have to check 1 gram magnesium is taken in this particular reaction. We have to check it is needed or not, or it is excess or limiting. See 32 gram oxygen combined with 48. What about 0.56? What about 0.56? 32 gram oxygen combined with 48 gram magnesium. What about 0.56? 0.56 divided by 32 multiplied with 48. After calculating this one, we will get the answer 0.84 gram. 0.84 gram. Actually 0.84 is needed here. But here taken how much? 1 gram. So this is the excess, right? Actually 32 gram oxygen combined with 48 only. 0.56 combined with 0.84 only. Here given 1 gram. So the amount is excess, right? Okay, a 0.84 is actually need, but given 1 gram, it is given 1 gram, so the amount is excess. So magnesium is the excess reagent. Magnesium is the excess reagent. How much? So we can subtract 1 minus 0.84. The answer is 0.16. So magnesium 0.16 gram. Answer is option A. The next one, question number 8. 10 gram of hydrogen. 10 gram of hydrogen and 64 gram of oxygen were filled in a steel vessel and exploded. Amount of water produced in this reaction will be hydrogen and oxygen combined to form water. Here this equation is not balanced, so we have to balance first. See here also both the amount of reactants are given. So we have to check which one is the limiting reagent, because the limiting reagent will decide how much amount of product is formed. So first we have to write the mass of the equation, that means molecular mass or atomic mass. Here 4 hydrogen, right? So that is 4 gram. Oxygen is 16, O2 that is 32 gram. Again write the mass of the given equation, 64 gram. Here also we have to check this much amount is actually need or not. See, 32 combined with 4 gram. What about 64 gram? 32 gram oxygen combined with 4 gram. 4 gram only. But here given 64 gram and 10 gram. This much amount is actually need. We have to check. Okay. So, 32 divided by 32 and 64. What is the relation? It is multiple with 2, right? 32 and we can take the conversion factor. That is easy. So 32, how 32 becomes 64? Multiply with 2, right? Here also we can multiply with 2. The answer is what? 8 gram only. So 8 gram hydrogen is actually need. But here given 10 gram. So this is the excess amount. Hydrogen is excess. Okay, 10 gram is actually need. But here given 10 gram, sorry, 8 gram is actually need. But here given 10 gram. So this is the excess reagent. This one is the limiting reagent. So limiting reagent will decide how much amount this product is formed. How much amount of product is formed. And also the amount of water produced. That is the question. Here 32 gram oxygen combined with answers are mole. So we can calculate the mole of water here. 32 gram oxygen, from 32 gram oxygen, water is formed 2 mole. What about 64 gram? 32 and 64, that is multiple with 2. Here also we can multiple with 2. Answer is 4 mole. 4 mole. How 32 becomes 64? Multiple with 2. Here also we can multiply with 2. So the answer is 4 mole. 4 mole water. Okay. Then next one. Next question, question number 9. How many hydrogen atoms? How many hydrogen atoms are present in 1 mole of water molecule? How many hydrogen atoms are there in 1 mole of water molecule? 1 mole water contain 2 hydrogen atom. Okay, 2 mole hydrogen, that is equal to 2 into 6.022 into 10 raised to 23. How many hydrogen atoms are there now? Number of atom equal to given mass or number of molecule into atomicity or number of mole into Avogadro number into atomicity. Here 1 mole of water, 1 mole of water equal to 1 mole of water equal to 2 mole hydrogen, contain 2 mole hydrogen. Convert mole into molecule, 2 into 6 into 10 raised to 23. Answer is 12 into 10 raised to 23 or 1.2 into 10 raised to 24. 1.2 into 10 raised to 24. Option is B. Then next question, question number 10, 10th one. What is the number of mole? What is the number of mole in 360 gram of water? Number of mole, no. Number of mole equal to what? Number of moles equal to given mass divided by GAM or GMM. GAM or GMM. So given mass is what? 360 divided by 18. 20 mole, right? 360 by 18, 20 mole. Option C. Then next question number 11. How many atoms of carbon are in 6 gram of carbon? Atoms, number of atom is equal to what? Number of atoms equal to how many atoms? 6 gram. So given mass divided by GAM or GMM into Avogadro number. Given mass is 6, right? 6 divided by atomic mass of carbon is 12. Multiplied with 6 into 10 to the power 23. Atom, right? Only one atom. Multiply with 1 into atomicity, right? Atomicity. So here what we can multiply. So here 2. 6 divided by 2, 3 into 10 raised to 23. 3 into 10 raised to 23. Option C. Then question number 12, last one. How many grams are in 1.2 into 10 raised to 24 molecules of CO? Here given molecule, right? Number of molecules equal to what? Number of molecules equal to number of molecules equal to given mass divided by GAM or GMM, that is multiplied with Avogadro number. Okay, here given what? Number of molecules is given 1.2 into 10 raised to 24. Calculate given mass divided by molar mass GMM 28 into 6 into 10 raised to 23. So given mass equal to what? 1.2 into 10 raised to 24 multiplied with the 28 divided by 6 into 10 raised to 23. After calculating, we will get the answer B. Option B. Okay. So let's wind up the session. Okay, thank you and all the best.